So, what is gallium arsenide technology? So, gallium arsenide is very famous now in all the photonic applications where you want to fabricate devices pertaining to optical communication or light-based communication. You are definitely going in for gallium arsenide, and this gallium arsenide is a wide gaining popularity, and it has special characteristics. You can have less than 1 micron gate. So whenever you devise transistors using gallium arsenide, you can fabricate sub-micron gate. 1 micron is 1 micrometer. So if you want to make even more lesser in width, I can go for less than 1 micron gate geometry. I can do. If I am going to go for a metal semiconductor junction, I can go for less than 2 micron metal, which can be fabricated. Up to 4 metal layers I can fabricate. I can make the device on and off devices using gallium arsenide fast because the electrons are present inside. Switching takes place very faster. And 4-inch diameter wafers are enough to fabricate your gallium arsenide devices. And the clock range will be in the range 1 to 2 gigahertz. So these are the typical characteristics of gallium arsenide devices based on their fabrication. Now, what makes gallium arsenide as a very famous technology? First one, electron mobility is very high. So when electron mobility is very high, electrons will have a larger velocity. They can move very fast inside the gallium arsenide material. So when the electrons are going to move very fast, they are going to take a very less amount of time. That time is called as transit time. So see here, improved electron mobility and resulting in very fast electron transit time. So electron can cross the depletion region very quickly. And the saturation velocity occurs at a lower threshold than for silicon. So saturation velocity occurs very fast. The electrons acquire saturation velocity very fast when compared to silicon. And one more thing, large energy band gap. See, the energy band gap is 1.4 electron volt, right? So this large energy band gap is enabling it to fabricate it as a bulk insulating substrate. So you can make a bulk, you can fabricate gallium arsenide technology as a bulk substrate device because you have a very huge amount of direct band gap between the conduction band and valence band. And these devices are very much useful, and they operate over a wide temperature from minus 200 to plus 200. That see it minus 200 to plus 200, the range is 400 degrees. So it can operate at very cold places as well as it can work well at very hot places. So you need not change the technology as you move the device from hot place to cold place. The same gallium arsenide technology can work very well in hot place, cold place, as well as room temperature excellently. And one more main thing, direct band gap. So because of direct band gap, gallium arsenide is going to be used as light emitter. It is going to emit light when you're going to bias it appropriately. And when you compare to silicon, this gallium arsenide device are going to have less power dissipation. Yeah, silicon more power dissipation na, because you have current flowing. When current is going to flow inside the device, it is going to produce heating effect, right? So because of that heating effect, the power dissipation in the silicon is going to be very, very large. When you compare that with gallium arsenide, we are not having any current. We are having emission of photon, and that photon I'm going to use it for all the applications, correct? So when you compare these two things, the power dissipation is very, 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 very minimum in gallium arsenide when you compare with silicon technology.